All right, so you know how sometimes you really want to understand something?
Mm-hmm.
You're like, okay, I want to get to the bottom of this.
Right.
But you don't want to be, overwhelmed.
Yeah.
You just want to have that aha moment, like, oh, okay, I get it now.
Makes sense.
So that's what we're doing today.
Okay.
We're talking about something that's like at the heart of learning,
Oh, wow.
particularly when you're dealing with problems that are complex problems that you can't just, Google the answer to.
Yeah. Yeah. No kidding. Those are the interesting ones.
Right, exactly.
Yeah.
So those are the ones that matter.
Mm-hmm.
And that's where this idea of like learning supports comes in.
Yeah.
Like if you're trying to learn a new skill,
Yeah.
like coding or even like cooking a complicated dish,
Yeah.
you're probably not just going to be thrown into the deep end.
No. Yeah, something.
Right. You need some help,
Yeah.
like a tutorial or a recipe or a friend who's really good at it
Oh,
who
yeah.
can kind of show you the ropes. And that's basically what we're talking about today.
Okay.
How these learning supports help us, especially when they're like computer-based tools,
Mm-hmm.
how those can help you really master that complex problem solving.
That's great.
Yeah, and to kind of guide our thinking today, we're drawing on some really cool research in educational psychology.
Okay.
And the big one is a paper called
Uh-huh.
Distributed Cognition as a Lens to Understand the Effects of Scaffolds, the Role of Transfer of Responsibility.
Wow. That's a mouthful.
Yeah, it is a mouthful.
Oh.
But we'll break it down.
Yeah.
And the reason this is so important, it's not just about getting good grades in school.
Right.
Problem solving is like, it's everywhere,
Yeah.
in our lives. It's how we navigate the world.
Yeah, you need it for everything, pretty much.
Exactly. And what's interesting is, people have looked at how well U.S. students do at problem solving
Oh, okay.
compared to students in other developed countries.
Right.
It's not as great as you might think. Yeah. So that's part of the reason we're doing this deep dive.
Right.
We want to understand how this thing, scaffolding, especially when it's delivered through like a computer program,
Yeah.
how that can lead to this really important thing
What is that?
called transfer of responsibility.
Oh, okay.
And that's the point where, you can ditch the training wheels.
Yeah.
You can take the reins and solve those tricky problems all on your own.
It's like you've really learned it.
Exactly.
You own it now.
Yeah. So let's start with the basics.
Okay.
When we talk about scaffolding in learning, what exactly are we talking about?
So, scaffolding, you can think of it like the temporary structure
Oh, yeah.
that builders use when they're constructing a building.
Right.
It's that support that bridges the gap between what you can do on your own
Mm-hmm.
and what you can achieve with a bit of help.
Makes sense.
Right. And so originally, this was really thought of in terms of human support.
Wait.
Like you have a teacher or a mentor who's giving you different kinds of guidance.
Okay.
So they might help you understand the key concepts,
Mhm.
or they might show you the steps involved in a procedure,
Right.
or they might suggest different strategies you could try,
Right.
or even help you think about your own thinking.
Okay. So it's like having a knowledgeable guide
Exactly.
to help you through a difficult task.
That's a great way to put it.
Okay, so then computers come along.
Right.
And now we have a whole new way
Yeah.
to provide these learning supports
Mm-hmm.
through computer-based scaffolds.
Right.
And these are designed to work alongside a teacher.
Yeah.
But there's a key difference.
What's that?
When a person helps you, they can adapt in real time
Right.
to how you're doing.
Exactly.
But computer-based scaffolds, they're more pre-planned.
Mm-hmm.
They're designed based on what the developers think students are going to find tricky.
Yeah, it's like they're guessing a little bit.
Yeah, a little bit.
Yeah.
Right? So it's not as intuitive.
Yeah. As a person.
No.
Okay. So it's kind of like training wheels for your brain.
That's a good analogy. but it's important to realize that research suggests
Yeah.
that just having those computer-based scaffolds
Mm-hmm.
isn't enough.
Okay.
It works best when it's paired with a teacher or a mentor,
Right.
someone who can give you that nuanced guidance.
Okay. So we use these scaffolds to learn and improve.
Yeah.
But what's the ultimate goal as a learner?
So that brings us to two important ideas:
Okay.
effects with scaffolding
Yeah.
and effects of scaffolding.
Okay. That sounds similar.
Yeah, so effects with scaffolding is simply
Yeah.
how much the scaffold helps you while you're using it.
Okay.
But the effects of scaffolding,
Yeah.
that's the lasting skills you gain
Mm-hmm.
after you no longer have the scaffold.
Okay.
So it's about what you can do on your own in the future.
Got it.
Right.
So it's not just about getting through this one task. It's
Yeah.
about learning how to do it yourself the next time. Exactly.
All right. So traditionally, how has this transfer of responsibility
Right.
been encouraged?
So the classic approach, and it's a cornerstone of scaffolding theory, is called fading.
Fading.
Yeah, and that's basically the gradual withdrawal of support
Okay.
as the learner shows that they're getting more competent at the task.
Okay.
So the idea is, as you demonstrate mastery,
Yeah.
the helpers, whether it's a human or a computer,
Mm-hmm.
they step back little by little,
Okay.
allowing you to take over completely.
Okay. That sounds good in theory, but our main source
Yeah.
suggests that this idea of fading might not be so straightforward
Right.
when it comes to computer-based scaffolds,
Yeah.
and especially for certain kinds of problems.
Yeah.
What makes it a challenge?
Well, it gets tricky when you're dealing with what are called ill-structured problems.
Ill-structured problems.
Yeah, think of these as like the messy real-world problems we talked about earlier,
Right.
where there isn't one right answer. And there are many different ways you could go about solving it.
Got it.
Like if you're trying to come up with a marketing strategy
Right.
or tackle a complex social issue,
Yeah.
there's no one set of steps to follow.
Right. It's not like an algebra problem
Exactly.
where there's a right answer
Exactly.
and there are rules.
Yeah.
That would be a well-structured problem.
Exactly. And traditional computer-based tutoring systems
Mm-hmm.
are actually quite effective for well-structured problems.
Yeah.
Because the correct steps are clearly defined,
Right.
so the system can easily track your progress and give you feedback.
Got it.
But with ill-structured problems,
Yeah.
it's really hard for a computer to tell
Yeah.
if your approach is correct because there might be multiple valid ways to do it.
So how have developers tried to implement fading
Mm-hmm.
in these more ambiguous situations?
So there have been some attempts.
Okay.
For example, some software that helps students diagram legal arguments.
Yeah.
They include hint buttons that you can click if you get stuck.
Yeah.
But the problem is the system still relies on
Yeah.
the programmers deciding what's correct.
Right.
And you might be developing a perfectly valid argument
Mm-hmm.
that the system just doesn't recognize.
Yeah.
Plus, it puts the onus on you to ask for help.
Right.
And learners don't always do that,
No, we don't.
even when they need it.
So the computer's not really reducing the support
No,
based on how well the student is doing?
not necessarily.
Okay.
Right? Other attempts at fading
Yeah.
have relied on the student's self-reporting,
Okay.
when you need less help.
Okay.
Or they've used a predetermined schedule
Mm-hmm.
where the support is removed at certain points.
But are we really the best judge
Right.
of when we're ready for less help?
That's a good question.
And if the help disappears on a schedule,
Right.
it's not really personalized.
Exactly.
It's like a one-size-fits-all approach.
Mm-hmm. And learning is definitely not one size fits all.
Okay, and then there's this other issue
Yes.
that our source brings up,
Yeah.
which is overscripting.
Right. And this is when the scaffolding provides so much structure
Mm-hmm.
that it actually gets in the way of learning.
Okay, so it can backfire.
Yeah, it can stifle your own understanding.
So when is this most likely to be an issue?
Well, it tends to be more of a problem for adults
Oh.
and high-achieving students
Mm-hmm.
because they often have their own ways of tackling problems.
Right.
And if the computer-based scaffold forces them into a rigid structure
Yeah,
that clashes with their existing knowledge,
right.
it can actually be counterproductive.
Interesting.
Right. And because current fading methods aren't always tied to a continuous assessment of your performance,
Right.
they might not prevent this overscripting.
Got it.
The scaffold could still be telling you what to do,
Right.
even when you already know a better way.
Okay.
Right. And another point is
Yeah.
the researchers who design the scaffold, they might have a specific way of understanding the problem in mind,
Yeah.
but you as the learner might develop other perfectly valid ways of seeing things.
Right.
So simply taking away the scaffold
Yeah.
doesn't automatically mean you've really taken ownership of the
Right.
problem.
We need to understand how that transfer actually happens.
Exactly.
Okay, so you're not saying we should just leave the scaffolds on forever.
No, not at all.
Right.
The point is that simply fading the scaffold during a learning unit
Mm-hmm.
might not be the best way to achieve that ultimate goal of you being able to use those skills on your own in the future.
Okay, so if fading isn't the answer, what is?
Well, this is where the concept of distributed cognition comes in.
Okay, let's talk about that.
I-
What does that mean?
So instead of thinking of your mind as the only place where thinking happens,
Yeah.
Distributed cognition suggests that cognitive tasks can be spread across people and the tools that they use.
Okay.
So think about using a map app on your phone to get to a new restaurant. Okay.
The cognitive task of finding your way isn't just happening in your head.
Right.
It's distributed between your understanding of directions, the information on the map,
Yeah.
and the GPS technology.
Okay, so the computer-based scaffold isn't just an external aid.
Right.
It's like a part of my thinking process.
Exactly.
Okay.
The traditional view often sees tools as separate from the individual, but distributed cognition sees you and the tools
Yeah.
as partners in a cognitive system.
Okay.
And this system has information flowing through it in what's called an executive function.
An executive function.
Yeah, which is basically the ability to make decisions and control the process.
Okay, and where this executive function is located is really important.
Absolutely.
Okay.
So while information can be stored in different parts of the system,
Right.
like in your head or in the software, the entity that controls the executive function is crucial for the system's adaptability.
Right, because if you haven't developed that decision-making ability, the system won't be as effective.
Got it.
Especially if you remove a part of it like the scaffold.
So in this distributed view, the combined power of me and the tool is greater than me alone.
Exactly.
Wow.
Right. Computer-based scaffolds can really change what's possible.
Yeah.
They can allow you to do things you couldn't do on your own. Like imagine a student using a simulation to understand a scientific concept.
Right.
They might not be able to grasp that concept just from reading a textbook, but the simulation allows them to interact with it, to experiment. And that changes their understanding.
So how does this change how we design learning tools?
Well, one way to think about it is through this idea of a spectrum of cognitive skills that range from general thinking habits to very specific knowledge. And from a distributed cognition perspective, not all of these skills need to be inside your head. Some can be supported by the tools you use.
So the goal isn't for me to memorize everything.
Not necessarily.
Right.
The idea is that as you interact with the system, you develop mental models or schemas that incorporate those tools.
Okay.
So going back to the map app example, you might not remember every street name.
Right.
But you learn how to use the map and the GPS. And that understanding stays with you even when you don't have the app.
So the key effect of these scaffolds is helping me build those schemas.
Exactly.
Okay, but I still need to be in control, right?
Absolutely.
I need to be making the decisions.
That's the key.
Right.
That executive function, making choices, exploring possibilities, deciding on the best course of action, that's crucial.
And the scaffolds should be designed to help me maintain that control.
Exactly. If the scaffold takes over all the decision-making, you won't develop those skills yourself.
And that's where mindfulness comes in.
Right.
I have to be engaged.
Exactly.
I can't just passively follow the steps.
You have to be thinking critically about what you're doing.
So how do we design these things to encourage that?
So the paper outlines 4 guidelines
Okay.
based on this distributed cognition idea.
All right, let's hear them.
So the first one is to support problem reformulation
Okay.
through something called qualitative modeling.
Okay, break that down for me.
So the idea here is that by actively reformulating the problem, thinking about it in different ways, you're forced to make choices about what's important.
Okay.
You're not just accepting the problem as it's given to you.
Right.
You're taking ownership.
Got it.
And that helps you develop your decision-making skills.
Makes sense.
And it encourages you to see the problem from multiple angles, which is part of being mindful.
Okay.
And research has shown that using prompts or tools that guide this reformulation can be really effective.
Okay. So if I'm not just told what the problem is, but I have to figure it out for myself, I'm going to be more invested in finding the solution.
Yeah, you're more likely to really understand it.
What's the second guideline?
So the second guideline is don't give specific end goals.
Wait, really?
Yeah.
Why not?
Because giving a very specific end goal can actually turn an ill-structured problem into a well-structured one.
Oh, okay.
If you know exactly what the final outcome should be, you're more likely to just follow a set path instead of exploring different options.
I see.
And making your own decisions.
Okay, so it's about me learning the process,
Right.
not just getting to the destination.
Exactly.
Interesting. Okay, what's number 3?
Number 3 is enable students to make comparisons between cases.
Okay, how does that help?
So by comparing different scenarios or examples, you can explore the consequences of different choices.
Okay.
You start to see what works and what doesn't and why.
Okay.
And that ability to weigh different options is really important for executive control. It also helps you be more mindful.
Okay.
Because you're seeing things from multiple perspectives.
So what kind of tools help with this?
So tools that let you analyze and contrast different situations or even model the same problem under different conditions can be helpful.
Got it.
And also incorporating reflection activities where you're prompted to compare your approach across different cases.
Okay.
That can be really beneficial.
Right. And the final guideline.
Okay, number 4 is have students work cooperatively.
Collaboration.
Yeah.
We hear about that a lot in education.
Right. And for good reason.
How does that fit into this whole distributed cognition idea?
So when you work with others, you have to explain your choices and justify your reasoning.
Right, yeah.
And that strengthens your own understanding.
Right.
It also brings in different perspective,
Yeah.
which helps with mindfulness. But it's important to structure the activity carefully to encourage positive interdependence.
Right.
And give students autonomy.
So it's not just about splitting up the work.
No, it's about the interaction.
Right, the discussion.
Exactly.
Okay, so it's interesting how all these guidelines emphasize me, the learner, being actively involved.
You're in the driver's seat.
Right.
You're not just passively receiving information.
Yeah, it's about me making the decision.
Exactly. And that's really at the heart of the distributed cognition perspective.
Okay.
It's not about memorizing facts.
Right.
It's about developing the skills to navigate complex problems, knowing how to use resources, and maintaining control even when the scaffold is gone.
The paper also points out that a lot of scaffolds
that
have been studied already incorporate several of these guidelines.
Like that collaborative concept mapping tool. It touches on problem reformulation, not having specific end goals, and encouraging cooperation.
And they even suggest that if you use that tool across different problems and then compare those experiences, it could address all 4 guidelines.
Exactly.
That's pretty cool. And it seems like some of the other scaffolds could be improved by incorporating more of these guidelines.
Right. Like maybe a modeling tool could have built-in features for collaboration. Or if students are given very specific goals, maybe those goals could be more open-ended to encourage more exploration.
Okay, so the paper also gets into some deeper questions. About this whole idea of viewing computer programs as part of a thinking system.
It's a bit mind-bending, isn't it?
Yeah, it's kind of hard to wrap your head around.
Yeah, how can a piece of software participate in thinking? But that's what this model argues. It's the interaction between people, tools, and their environment that makes up the cognitive process.
So it's not like the computer is conscious or has its own intentions.
No.
But it does play a role.
It shapes how we think.
And what does it mean for a student to take responsibility in this framework?
Right.
Do I have to memorize everything?
Well, the paper suggests that maybe that's not realistic.
Okay.
Or even how it works in the real world.
Right.
Maybe transfer of responsibility means knowing what information you need, knowing how to find it, and being able to create a plan.
Okay.
Even if that plan involves using tools or collaborating.
So it's about being resourceful.
Exactly.
More than just knowing a bunch of facts.
Right.
And the paper also talks about how this relates to metacognition.
Right. Thinking about your own thinking.
That's self-regulation.
Yeah, setting your own goals.
Okay, so those are connected to this idea of executive control. But the research suggests that guidance from a teacher is still really important.
Yeah, for developing those aspects. So it seems like a combination of well-designed scaffolds and human instruction is the best approach.
Okay, and that concern about over-scripting, where the scaffold becomes too restrictive, that's still something to keep in mind.
Absolutely.
As they get more skilled.
Right.
Those scaffolds might not be helpful anymore.
And they could even hold you back.
Okay, so more research is needed.
Definitely.
To figure out how to make scaffolds that adapt to my progress.
That's right.
All right, so this distributed cognition model, it gives us a new way to think about learning.
It does.
Especially with technology. It's not just about taking away support.
No.
It's about empowering us to take control of our learning.
Exactly.
So just to recap, we're shifting from this focus on fading
Yeah.
to understanding distributed cognition
Right.
and the importance of maintaining our own executive function.
Within that system.
And those 4 guidelines for designing good, computer-based scaffolds,
Yeah.
they all support us in doing that.
They do.
And they help us become better problem solvers.
That's the goal.
So now for a final thought. Think about how this idea of distributed intelligence might apply to other areas of your life.
Interesting.
Not just learning.
Yeah.
Where do you collaborate with tools or other people to achieve complex goals?
Good question.
How does understanding this distribution of thinking change how you view your own abilities?
Yeah.
And the design of the systems around you? We encourage you to check out the research we talked about.
Yeah.
And think about your own experiences with learning and problem solving.
That's great advice.
Thanks for joining us for this deep dive.